Hello guys and welcome back to the 17th video of our graph playlist, and today we will be solving the problem from the Leetcode. So if you are new to my channel and started with data structure called as graph for your DSA interview, then I would highly recommend you to go through my previous video, because over there I have discussed in detail about the graph data structure and what are the things that you need to know to solve any problem on graph during your technical interview. So without wasting much time, let's start with today's problem, and that is the surrounded region. So let's first go through this problem and let's first understand that what it actually tells. So here if you look carefully, this is the 4x4 matrix that is given, and it is telling that we have to connect all the zeros together to form a region, and the region can only be defined as a valid region only and only if it is surrounded by x on all the four sides. So here if you look carefully, this zero can be connected with its adjacent zero, that is this one. Similarly, it can be connected with its adjacent neighbor, that is this one. So if you look carefully, this island that we got over here by connecting all the zeros is surrounded by this 2x at the top, this 2x at the right hand side, this 2x on the downside, and this x on the left hand side. Means the new region that got formed by connecting the zeros are covered by x on all the four sides over here. And if we can find out a region by connecting all the zeros which is covered by x on all the four sides, then what we have to do? We have to replace that valid region that was given with 0 to x. So here you can see this was the initial structure of our matrix, and since this is a valid region, we have to convert it into x. Means this 0 will get converted to x. This will also get converted to x. Similarly, this one will also get converted to x, and thus this 3 will get converted to x. So this is a valid region because it is surrounded by x on all the four sides. Similarly, if you see this 0 which is lying over here, you can see this is on the boundary, and here if you see, though it is covered by x on all the three sides, there is no x that is on the downward direction. So we cannot say this is a valid region, and since it is not a valid region, so we will keep it as is and we should not replace it with x, and thus this is your answer. And this is what you have to return. Hopefully this is clear what the problem statement initially tells. Now let's see what can be the possible other condition and how we can solve this problem. So if we consider another example, for example, this one, here you can see similarly, since this is the only zero available over here and on both of the side there are no x, so obviously this is not a valid region, and thus we have to return the same output that we got as an input. Means this will be our output. Similarly, if I get something like this, means for this 0, since all of them are covered by x on all the four sides, so our matrix will get converted to this thing, and this would be our answer. So I hope this is clear that what the problem statements say. So believe me, solving this problem is practically very easy if you can manage to find out a pattern on this problem. So if you look carefully in all the three examples that I have provided over here, there is a simple common factor, and that is any zero that is present on the boundary cannot be converted to an x, because a boundary is bound to have an undefined border. So for this 0, there is no boundary or x present on the downward direction. Similarly, for this 0, there is no x on the top and the left hand side. So obviously this cannot be converted to x. So this is a key observation that you have to keep in mind for solving this problem. But if you see, for this problem, this 0 was not the part of this boundary, and that is why it was possible to convert this 0 into x, since all the x's are present on all the four sides. But there is one condition. Let me give you one more example. So for example, you are given a matrix something like this. And for this case, if you see, since this 0 is present on the boundary of our matrix, so very obvious there is no x that is present on the left hand side. So converting this 0 into x is not possible. That we already got to know from these three examples. But if you look carefully, since this 0 is also connected to another 0 internally, so this internal 0, while it gets connected and form a region, can also not be converted to an x, because one of the 0 which have formed an island was part of the boundary. So the concept is very clear. What we have to do? We have to see that what are the zeros that are present on the boundaries of this matrix. And if there is any zero present on the boundary, we are confirmed that we cannot convert that zero to x. That is fine. But we have to also see that the zero that we have found on the boundary, whether that zero can form a region or not by connecting the zero that are present on its neighbor. So over here, if you see, for this zero, since it is part of the boundary, it is not possible to convert it to x. But here if you see, for this node, there are some adjacent zero to it which can form a connected component. So here if you see, this is the adjacent zero which can form a region. Similarly, for this zero also, there is another zero present on the neighbor which can again form a region. And since all of these zeros are connected together and forms a single region which is a part of the boundary, and hence we cannot convert this entire section, means this entire region, to x. Since we are sure that there is no x present on the left hand side of this zero, since it is on the boundary. So here this zero is basically the culprit for which this zero cannot get converted to x. So this is actually the main logic with which we will be solving the problem. But here if you see, for this zero, since this is an isolated zero and it is not connected with any zero on the boundary, so obviously all the four sides will be having an x, and this is a valid region and we can easily change this valid region to x. So our answer will be something like this. So this will be our answer. I hope this is clear that with what intuition and logic we will be solving this problem. Now if you have understood this approach of how we are solving this problem, then implementing this solution is pretty easy, because you already know how to do a BFS and a DFS traversal for a 2D matrix, because I have already covered that video in the lecture 7 and 8 of my graph playlist. So let's see how we will solve the problem. So the way we will be solving this problem is pretty easy. So what we will do, since we are concerned with all the nodes that are present on the boundaries, so we will start our traversal from the boundaries and we will try to check whether there are any zeros that are present over there on the boundary or not, because that zero will be our culprit and that will help us to find out that whether a region can be converted to x or not. So what we'll do, first we will start our simple iteration on the boundaries. So let's take an example that for the first iteration, we will iterate on this first row, that is this row, and we will try to find out whether there is any zero present over here or not. So here you can see 0 is not present in any of the cells. So it is not a problem. So what we'll do, we will check the next boundary, and the next boundary is this one. So here we will again check whether any 0 is present on this boundary or not. So none of the element over here is 0. So not a problem. Now what we'll do, we'll check the next boundary, which is this one. So here why we will be iterating, we will see for the first item, this is x. But for the next node, that is this node, which is nothing but 1, 0, for this node, this is a 0. So if I just mark the indexes of this matrix, it will look something like this. So here if you see, for this node, that is 1, 0, this is a 0 or a O that is present over here. So obviously this node cannot be converted to a x that we know from our observation. So what we will do, instead of converting to x, we will convert to a different thing. That is, let's tell we will convert it to t. Now we will check that from this t or this O, what are the other region that can be possible to form starting with this index. And for that, what you need the concept of the connected component, which I already have taught you in my previous video. And how do we find out? We can simply run a DFS or a BFS algorithm from this node. So what we'll do, we'll first call a DFS from this node, that is 1, 0. And here we will check what are the neighboring nodes, and the neighboring nodes can be only on the horizontal and the vertical direction. So we will first check on the top hand side, and it is x, so we'll ignore it. On the right hand side, we can see there is a 0. So what we'll do, as per the algorithm of DFS, we will go to this node. We will call the DFS of 1, 1. So here this is a 0. And since this 0 is a part of a region which is formed by a 0, that is placed on the boundary. So what we will do, we will also convert this 0 into t. Means this 0 cannot be converted to x. So we will mark it as t. Understood? Now what we'll do, again from here we will again check whether there is any connected component or connected node to it or not. So here you can see, we will first check on the top, it is x, we'll ignore it. We'll check the right hand side, we'll see it is x, we'll ignore it. Here on the downside you can see it is 0, means it is again a possible region which we can expand, and thus we will include it within our region, and thus we will call the next DFS, that is DFS of 2, 1. And here once we come, we will mark it as t, since it is not possible to convert it to x. Now what we will do, we will again check whether it is possible to expand our region or not. So what we'll do, we will again call the DFS from this node, that is 2, 1. And here if you see, all the neighboring nodes over here, which is nothing but these 4 nodes, are either x or t. Means it is not possible to expand our region of 0 over here. So what we'll do, we will return back from this DFS call. So we are right now at this node. And again from this node, we will again check whether there is any unfinished DFS edges or any pending neighboring nodes or not. And here you can see no nodes are pending to be covered, means we cannot expand our region anymore. Thus we will return again. Similarly from this node, that is 1, 0, we will again check whether we can expand the region or not. And you can see we cannot expand, and thus we will return from this function. And thus at the end of this complete iteration, you can see our matrix got converted to something like this. Means we have x on all the edges, and here all the zeros that were present, that got converted to a temporary variable, that is t. So thus we are done with this DFS traversal, which was starting from the node 1, 0. Now what we'll do, we will keep moving forward. And for that, what we'll do, we will move forward with our iteration that we were doing on our boundaries. So we'll go to the next node, that is this one, and this is our x. So we'll not do our DFS from here. Again, we will keep on moving forward. And here, since there are no more zeros over here, and we can simply complete our iteration. Now the last boundary that is present is this one. So here in this boundary also, you can see all the values over here are x, and thus we can simply complete our iteration. So here what we did, we did 4 iterations. One on this boundary, one on this boundary, one on this boundary, and one on this boundary. And while we were traversing, we are checking that whether there was any 0 present on the boundary or not. And if there was any 0 that was present on the boundary, we were converting it into t, as well as we were starting a DFS call from that 0, and we were finding what are the connected components that are present, or what are the regions that we can expand. And if we have found out any region of zeros that are connected to the boundary 0, then what we were doing, we are also converting that 0 into t. And thus at the end of this complete iteration, this is how our matrix will look like. And if you look carefully, this is actually the answer that we are looking for. So what we have to do, if you look carefully to the problem statement that was given, here it was telling that we have to simply return the matrix in this way. Means we have to simply convert the 0 into x if it is a valid surrounding, otherwise we have to keep it as 0. So what we'll do to make it align with our problem statement, we have to simply iterate over this entire matrix, and we have to see whether there is any 0 that is left in this matrix or not. Means you can see here, this is the only 0 that is present over here, and if there is any 0 that is remained untouched, means it is not connected to the boundary, we will simply convert that 0 into x, and that's it. And what will happen to the t? If we found a t, we will simply convert the t into 0, means we will reset the value to it. So at the end of the complete iteration of the matrix, how it will look like? It will look something like this. And thus at the end of our complete iteration, this is how our answer will look like. Means only 3 zeros over here, and this 0 got converted to x. I hope this is clear that how we are solving this problem. And believe me, if you have understood this approach of how we are solving this problem, implementing it is a very easy process because it is just a few lines of code and a few logic that you have to just understand. So let's start with the implementation using the same old code that we have used previously. So let's start with the implementation of solving of surrounding region problem of Leetcode. So here if you look carefully, this is actually the solution of this problem. So we'll go line by line and we'll try to understand that what we are doing. This is pretty simple and very easy to understand. Just stay with me. I will explain you line by line so that it will be very easy for you to understand. So let's see what we are doing. So here we are given a function called as solve. And in the parameter, we are given a 2D character matrix called as board, which is nothing but this one. Now what we'll do, we are simply doing an input check that whether the input that is provided is correct or not, whether it is null or undefined or not. And if it is undefined, we are just simply returning it from here. This is clear. Now what we'll do, we will simply creating the two variable to get the configuration of the matrix, means to count the total number of rows and the columns over here. Now let's start with the actual implementation that we need to solve this problem. So what we are doing here, if you look carefully, we have started our iteration on the two borders or the two boundaries of the matrix that we have discussed right now. So here for the first time we have started our iteration on the first row and the last row of our matrix. So here if you see, I'm running a single loop, and with the help of this single loop I am traversing the first row that start with 0 index. Similarly, we are also checking the last row of our matrix, the row -1, means n -1. So these two are nothing but the first row and the last row of our matrix. And here we are checking that whether the value present over here, means the value of the node, is 0 or not. Because if we found a node that is 0, means we have found the culprit in our system. So what we are doing from that node, if it is a 0, we are calling a DFS over there. So we'll see the DFS functionality, how it is implemented later. Now let's check what are the other thing that we are doing. Similarly, over here, we are checking the first and the last column, means these two columns. So here you can see this is the first column, that is why the column value is 0. Similarly, over here, the column value is n-1, means the last column. So again, on both the column, we are checking that whether there is any 0 present or not. And if there is a 0 present over here, we are calling the DFS function to find out the connected component of 0. So this is clear how we are starting our function. Now let's see what we are actually doing in the DFS call. So what we are doing in the DFS call is very easy. So here if you see what we are checking, we are just checking whether the index that is provided over here is valid or not. That is a very basic check that we do for any DFS call, which we have implemented with the functionality called as isSafe in our 7th and the 8th video. So I hope this is clear to you. Now what we'll do, if the value is out of bound of the matrix, so we will simply return it from here, means no traversal is possible because it is out of bound of your matrix. But if it is possible to do a DFS traversal over here, what we will do, we will simply mark it with a temporary value, that is t. I hope now it is clear to you why we are marking it as t, because I have already explained you in detail. So what we are doing, we are simply marking the value as t, and from there what we are checking, what are the other possible neighboring nodes of the graph which are having the value of the 0, means whether we can expand our connected node with 0 or not. So we are starting our iteration, means we are calling our DFS functionality for all the possible 4 direction, down, up, right and left, and you can see the coordinates are changing accordingly. This is the same thing that we have implemented, but in a different style. I am showing you both the styles so that it will be easy for you to grab any of the concept that you get used to it. So what we are doing, we are simply doing a DFS traversal on all the 4 sides, and this is a recursive call, means if there is any valid entry, we will again mark it as t and we will keep on moving. So here recursively using the DFS algorithm, we are marking the zeros as t if it is connected to the boundary. And that's it. This is what you have to do. And once you are done with this complete iteration, means calling all the DFS from the border or the boundary, we are done with the answer. We just have to sanitize our answer and we have to make it the way the Leetcode wants. And that is, here we are again iterating over the complete array. And here we are checking that whether the node is having 0 or not. And if a node is having a 0, means by anyhow we couldn't touch that node from the boundary, and it is possible to convert it to x. And thus we are here can see we are converting this value into x. And if there is any cell that is present as t, which we have marked as a temporary variable, what we are doing, we are simply converting it to 0, means we are resetting the value. And that's it. With this logic, you can simply solve this problem. Let me click on run. Here you can see both our test case got solved. I hope this is clear how we are solving this problem with the help of a simple observation or the concept that whatever the 0 that are present on the boundary cannot be converted to x, and whatever the region that are connected to the boundary 0 can also not be converted to x. So thus, let's submit this code and let's see whether it's clear all the test cases or not. And here you can see all the test case got clear. I hope you have thoroughly understood this video and you have found this video useful. And if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So see you on our next video where we will be solving another problem on graph from Leetcode, and we will see how easy it is to solve any problem on the graph with some of the basic concepts which I have discussed in my channel. So see you on our next video. Thank you.